So, welcome back, everybody, to the podcast of the InnCoCells Consortium. And today we're joined by Frederick Borgard from Plant Advanced Technologies. Very nice to have you on the podcast, Frederick.
Thank you, Richard. I'm happy to be here.
I'm very happy to have you here because I've been actually looking forward to this one because for the benefit of our listeners, Plant Advanced Technologies has got a fascinating technology which Frederick's going to tell us about. Basically, the plants are grown using aeroponic facilities. And I'd like, actually, Frederick, to maybe explain for our listeners what that means for those of you who don't understand.
So basically, aeroponic conditions, aeroponic cultures are plants that are cultivated, I would say, on the air. But more specifically, plants are cultivated on tables and with holes. We have a small basket for each plant, and the roots are freely going through the basket, and they are hanging freely in the atmosphere on this part of the compartment of culture. And basically, how can they grow without soil or any normal device that you would find with a plant in a pot or on earth? Well, basically we spray a mist of liquid medium that contains basically water mainly and the minerals, very simple minerals. So we spray this medium in very fine droplets, so it soaks the roots, and the roots get both the water and the minerals from this process. And that's what we call aeroponic culture. You may know, or our listeners may know, maybe hydroponic cultures. Hydroponic is the fact that you cultivate the roots and they are in the water all the time. So like in a pool. And in aeroponics, well, the roots are just in the air most of the time. And every 3 to 5 minutes, they are sprayed with this culture medium. That's it, basically.
And what's the advantage of doing it that way? What's compared to, say, hydroponics?
Well, the advantage first is that plants grow really well with this technique, much better usually than with hydroponic conditions. And the other big advantage for us is that we are paying much attention to the root compartment, because that's where you will find most part of the active molecules in a plant. And so when it comes to the root, we'd better have a technique of culture that gives access freely to the root compartment. And that's what exactly aeroponic does for us, the technologists.
That's really clever. So basically what you're saying is that whereas if you grow a plant in soil, when you want to collect something from the roots, you'd have to pull the plant up, then clean all the soil and muck off it and everything. Whereas with aeroponics, it's already clean, it's already accessible, and you can just go in there and harvest them without any of these constraints.
Absolutely. And even more than that, if you grow the plants in pots or in soil, you won't be able to take out most of the roots, especially the thin roots, which are the most concentrated in active substances. You will leave them right in the soil because there is no way to pull them off the soil. And so aeroponics is a very efficient way to have a lot of thin roots accessible for any use.
Excellent. So would you like to briefly say which parts of the InnCoCells project your company is directly involved in, and maybe a little bit about its role in each of those areas?
Yes, with pleasure. Well, actually, we're involved in most, if not all, the work packages, simply because as other companies involved, we start from the genetic resources, so basically the seeds. And we learn to grow the plants in aeroponic conditions. We improve the growing conditions because, of course, we can play on the mineral composition, for instance, on the growth parameters surrounding the plants to help them grow and also help them synthesizing the molecules of interest. And then we have to extract those molecules from the roots, stabilize the extracts, characterize the plants and the extracts in terms of chemical composition. So as probably most of the companies, we are contributing to most, if not all, the work packages.
So for the benefit of our listeners, the way the project is organised, we have different work packages, so-called work packages, each of which has got a particular aim. And what Frederick is talking about here is that the early work packages, their objective in the project is to select which plants we're going to actually work with, then find the format in which they're going to be grown. So this may be cell cultures, this may be hairy roots. In Frederick's case, it will be aeroponic cultivation, or it might be whole plants growing in the soil or in the greenhouse or in the field. And then there's another work package to scale this process up so we can have industrial quantities of the biomass, which we're going to then extract the ingredients from. And then the next work package is doing the extraction, optimizing the extraction, and then the next one is to test. So covering all those must be quite exciting to be able to follow that process right from the very beginning, almost to the very end.
Yeah, absolutely. It's a great series of tasks that we have to monitor, and for this we have the help of all other partners of InnCoCells, and that's a great chance for a company like PAT to be in the capacity of networking with all those wonderful specialists we have in the project. So that's an immense added value of InnCoCells for a company like ours, to be I would say with the best of the best in terms of science and technology.
Excellent. Obviously, I'm not going to ask you to give away any trade secrets or anything, but can you explain maybe a little how you get from taking a plant that you've not worked with before and establishing whether it will work growing in an aeroponic environment? Do some plants fail this process, or can you generally make any plant grow in an aeroponic facility?
We could say that we certainly can grow all the plants, but not all the plants will produce enough fruits to be used in the process of our technologies. So yes, there's a selection that needs to be made in terms of root production, root synthesis by the plants, and that's a big step of the project. So that's mostly what we've done so far, selecting a couple of plant species that are perfectly suited to the production of an important root system, as well at the same time the occurrence of very peculiar, very interesting metabolites, natural molecules found in these roots. So we look for a good growth for the roots, but at the same time for a great originality in terms of natural compounds composition. And so it's not an obvious criteria. So there's quite a lot of attrition in terms of plants that we select. And in InnCoCells, we started with, bibliographically speaking, we worked on the base of maybe 80 different plant species based on bibliography. We selected something like 30 best candidates, and at the end we grew something like, I think, 23 or 24 species, and now we've just selected the best 4 of them. So that's where we are. We started from 80 and now we have 4 plants.
So was there any sort of external constraint on this selection, or was it all down to biology and capability in terms of the synthesis of compounds? Do you have any, for instance, I know that we have to be careful with the Nagoya protocol, and maybe our listeners would be interested to learn how that works and what it entails.
Yeah, of course, this is something that we have to consider, and we pay great attention to this so-called Nagoya protocol. Basically, Nagoya protocol is an international protocol signed by our European countries, establishing that when there's a benefit, when there's an income from plant resources that was accessed somewhere in the world, the country where this plant belonged to and people from this country will receive a part of the benefits. That's what we call benefit sharing. And yes, of course, so we pay a lot of attention of this, and just to know where we should address the benefit at the end, or with whom we should share this benefit, we have to know very precisely the origin of the genetic resource. It's not because you buy this resource from a German or English or French supplier that it necessarily comes from Germany, England, or France. So there might be intermediary partners that have provided a plant coming from abroad, or sometimes from a quite far country. So yes, we have to establish very firmly all the traceability as regards the origin. That's something. But not only this, since we intend to propose to the customers and the market new ingredients, we'd like to bring something new, not only because it's new, because it will help resolving a specific problem, maybe in cosmetics related to skin, could be redness or things like that. We are always looking for efficacy, and so we pay attention to the market related to these different sectors. Could be skin aging or skin inflammation, and we look very carefully at the fact that is a plant already used in these different sectors, or is it something new, and can we bring something more efficient to the market as regards these little problems we have all with the skins. That's basically what we consider.
Okay. What you've told us here brings up another interesting question, because I'm interested to learn, in terms of your expertise, where are you coming from? Were you firstly interested in plants and growing plants, and then this became an opportunity to make cosmetics, or were you originally interested in bioactive molecules and you landed on plants as a way to produce them? Or how did you become interested in this field, in this particular area?
Okay, so biology was always a passion for me, and especially plants. So my first part of the career was as an academic assistant and then academic professor. I've spent almost 30 years in the academic sector, always related to natural compounds from plants. So that's my research activity that I have developed over the years. And it's a great domain because it can help in many different ways. I mean, as humans, could be pharmaceutical compounds, could be compounds with health benefit when we eat some food, and of course including cosmetics. And it happened that now about 17 years ago, we decided with two other of my colleagues and friends, to tell the truth, that we could certainly create a company that would employ this specific technology related to plant aeroponics. And we used to call this technology plant milking technology, because basically we can recover the compounds out of the roots several times a year, still with the same plant and root material. So there's the idea to milk the plants as you would do with a cow. And so that was the starting of the adventure. And our project at the origin was to mostly focus on pharmaceutical sector, but it happened that the cosmetic industry responded very positively to our technology. They heard about us by press releases and things like that, and they came to us asking if we could work for the cosmetic industry, which I didn't know that much at that time, but basically this is the same. Of course, the products are different and we are not targeting the same problems, obviously, but the way to develop an active ingredient, being cosmetic or pharmaceutical ingredient, is quite similar. Of course, the regulations are completely different, but in my company we do both. I mean, we do cosmetic ingredients, but we have also a pharmaceutical division called Temisis, targeting some specific problems, skin problems like psoriasis, atopic dermatitis, for instance. So this sticks very well together.
And the technology is basically the same for both. It's just the application of the product is different.
Absolutely. The technology, especially to discover, to find out molecules out of the roots, is exactly the same. Then it's a matter of how hard the molecule is acting in your biological process that you're assessing. Obviously, the most potent active molecules go to the pharma industry, and something with a milder effect, but still efficient, go to the cosmetic industries. And now it's been 5 years that I've left my academic career and integrated my company 100% of my time.
So do you, I guess you must still interact with a lot of academics in terms of, because this is where the research comes from for the company to take over. And have you been involved in lots of Horizon projects before?
We've been involved, well, I don't know how far go these Horizon projects. We were involved recently in a Marie Curie training action, so related to the discovery of new molecules and ingredients from bryophytes. So the project was called MossTech, like moss and technology. But it's over now, it's finished. And we have another European project. It's a Eurostar project that is concerning our pharmaceutical division, Temisis. And since we have a project quite advanced in in terms of pharmaceutical development. We got some funds, and we are leading a European Eurostar project related to the discovery of molecules and the use of molecules against psoriasis. So it's quite a few European projects that we have.
So what would you like to see, I mean, personally, from your personal perspective, and also on behalf of PAT, what would you like to see the InnCoCells project achieve?
Well, I think there's a very unique, and I'm not saying this because I'm just here in front of the microphone, but there's a very unique set of expertise with all the 17 partners we have in InnCoCells, from academic to industry to associations, and also the stakeholders that are involved in the project. I think we have the capacity to develop cosmetic ingredients based on efficacy, based on smart technologies that will not commit nasty effects on the environment. And so we have technologies using very wisely resources. My belief is that, this type of consortium is not so frequent in the cosmetic industry, and we can certainly establish some new, maybe not rules, but levels of efficacy and mechanism of actions related to the product that we will develop. So this expertise is really uncommon from my perspective.
I think, as far as I know, correct me if I'm wrong, but I think InnCoCells is the only Horizon project at the moment which is dealing specifically with cosmetics.
True. Yeah.
There's a few. We have recently joined a cluster of projects funded under the same instrument, which have a common overarching theme of extracting bioactive molecules from, for instance, algae or from marine sources, and in our case, terrestrial plants. But yes, we're the only ones dealing with cosmetics, and as you say, it's a extremely broad academic and SME stroke industrial combination. And personally, I think it's going to be very successful, and I hope you feel the same way, Frederick, because it's with PAT on board and all the other SMEs, there's a lot of expertise behind it.
Thank you.
Okay, well, that's about it for this edition of the InnCoCells podcast. It's been absolutely fascinating talking to you, Frederick. Thanks ever so much for coming along. And thank you to our listeners for joining us again. We look forward to you listening to us next time. And thank you and goodbye.
My pleasure. Thank you, Richard.